Today, let us discuss about the support reactions. In support reactions, what are the expected questions? First one, they can ask you about what are the various types of supports. So, what you have to write? One is the simple support. Second one, it can be roller supports. Then another type of support is hinged or pinned support. Then fixed support. So these are the various types of supports you have to mention. Then you have to explain what is a simple support. So first one is simple supports. What are simple supports? Simple supports are those which exert reactions perpendicular to the plane of support. They restrict the translation of body in one direction only. Okay, so simple supports are those which exert reactions perpendicular to the plane of support. They restrict translation of the body. They restrict translation of the body. Okay. In one direction only. In one direction only. Okay. But do not restrict rotation. But do not restrict rotation. Okay, so these are the simple supports. Okay, so we can represent a simply supported beam like this. Okay, either we can represent it like this. Okay, then or we can represent like this, and the reactions, there will be vertical reactions, that is perpendicular to the plane. Suppose this is point A, this is point B, then RA is the reaction at A, RB is the reaction at B. Okay, so these are simple supports. Then second one, roller supports. What are roller supports? They are represented like this. So the roller supports, suppose this is A and B, roller supports are those which exert the reactions perpendicular to plane of the support. Okay, perpendicular to plane of support, and they restrict the translation of body along one direction only, but rotation is allowed. Here in simple support they do not restrict rotation. Okay, and here the rotation here also it is allowed. So here you can write RA, RB at A and B. Okay, so these are the roller supports. Then what are hinged or pinned support? Hinged or pinned supports are those which exert reaction in any direction, but for our convenience. What we do is we resolve the reactions in two components. Okay, so hinged supports restrict translation in both directions, but rotation is possible. Rotation is possible. Okay, so it is represented like this, hinged support. Okay, and how we resolve them? Suppose this is point A, this is point B, A and B. Okay, so this is RAY, RAX and RA. This is RBY, RBX. This is RB. Okay, so these are the hinged supports. Then last one is the fixed support. What are fixed supports? They restrict both translation and rotation of the body. They develop an internal moment known as the restraint moment. So, how to represent a fixed support? So, this is a fixed support at A and B, and reactions here will be RAY, RAX, RA, RBY, RBX. In addition to this, there will be a moment, that is MA at point A and MB at point B. So, this is the restraint moment. Restraint moment. So, if they ask you to explain what are the various types of supports, you have to explain all these types of supports. Then, second, what they ask is, what are the various types of beams? See, in this module, you have one more option of truss. But compared to truss, the support reactions are very, very simple. Even the theory part and problem part. So, you can attempt this module. That is this bit in this module. Okay. So, first one is the simply supported beam. And simply supported beam means it consists of the simple supports. Okay, we have studied about simple support. So, simply supported means a beam which has the simple supports is called as the simply supported beam, and it can resist the forces normal to the axis of the beam. Normal to axis of beam, it can resist the forces. So, we can write like this, simply supported beam. Then, what is a continuous beam? Continuous beam, second one is continuous beam means there are three or more supports. Okay, like this, it is a hinged support, there is a roller support, and there is one more hinged support. So, three or more supports are there, then it is called as the continuous beam. Then, third one is the cantilever beam. Cantilever beam means it is a beam whose one end is fixed and other end is free. This is fixed end and it is free end. It is called as cantilever beam. Then fourth one is what is propped cantilever. Propped cantilever means if you add a support at free end for this cantilever beam, it is called as propped cantilever beam. So first you have to draw a cantilever, and if there is a additional support, that is a beam whose one end is fixed and other end is simply supported, then it is called as the propped cantilever beam. Then last one is the overhanging beam. There are two types in overhanging beam. Okay, that is either it is a single overhang or there is a double overhang. Single overhanging beam or double overhanging beam. Okay, so single overhanging beam means, suppose this is a beam with hinged and roller support. There is only overhang this on one side. This is the overhang, means protrusion. Okay, so this is a single overhanging beam. Double overhanging beam means there are two supports and it is having overhang on two sides. So it is called as the double overhanging beam. So these are the various types of beams. Next, what they can ask is important, that is what are the various types of loads. Types of loads. Okay. So types of loads, first one is the point load or concentrated load. Okay. So a load which is concentrated at a point in a beam is called as the concentrated load. So it acts at only one point. These are all point loads or concentrated loads. Then second one is the uniformly distributed load, or it is called as UDL. It is spread over certain span. It is represented by certain intensity like W kilonewton per meter. It is spread over some m meters. Then its magnitude, we can convert this into a point load like this. Okay, that is, it acts at center, that is W into M. It will be the magnitude of the point load and it acts at, suppose this is L meters, then L by 2, always it acts at half of the span over which it is spread. Next is uniformly varying load, called as UVL. UVL, it is the intensity is varying, or a triangular load, it is like this. Okay, that is called as the uniformly varying load. Suppose, let me take 2 kilonewton per meter, then spread over 2 meters. Okay, then the area of this triangle will be the magnitude of point load, equivalent point load if I want to represent. Then it will be half into base is 2 meters into its intensity is 2. So it will be 2 kilonewton. That is 2 kilonewton will be magnitude of the equivalent. You can replace this UVL with this point load by taking half into base into its intensity 2 kilonewton, and where it will be acting at its CG. For triangle, we all know it is at 2/3 of 2 and 1/3 of 2, right? So it will be acting at 2/3 of 2 from the apex and 1/3 of 2 from the base. Okay, so this is very important. While solving problem, you have to remember, if the UVL is given like this, then here it will be 2/3, here it will be 1/3. So we have to carefully take moment. While taking moment only, this will come into picture. Okay, next let us solve the problems on support reactions. First, they have asked to determine reactions at A and E for the given beam. So, let me draw the beam given. It is a hinged support here. Okay, and first there is a 100 kilonewton point load. It is at a distance of 3 meters. Okay, Then there is UDL of 20 kilonewton per meter. 20 kilonewton per meter, there is UDL, and it is spread over a distance of 3 meters. This is point A, B, and this is point C. Okay, and in addition to this, there is a moment of 100 kilonewton meter at C, and there is an inclined 200 kilonewton force at an angle of 45 degrees, and at here there is a roller support. Okay, so this is 3 meters and it is also 3 meters. This is point D, point E. They are asked to find RA and RE. We have to find. How to find RA and RE? First, let us convert this UDL into a point load. Okay, so UDL, it is given 20 kilonewton per meter and it is spread over 3 meters. Let me convert that into point load. So this 3 meters at center, 20 into 3. Okay, that is 60 kilonewton, and it acts at, this total is 3 meters. Here it is 1.5, 1.5, exactly at center that point load will act. Okay, then we can resolve this 200 kilonewton inclined force, that is vertical will be component 200 sine 45, horizontal is 200 cos 45. Okay, now let us write the simplified sketch. Here it is RA, it is RE, point A, at point B there is 100 kilonewton and this 60 kilonewton. At point C there is a moment of 100 kilonewton meter. Okay, this first distance 100 kilonewton, it is at 3 meters. Then 60 kilonewton, it is at 1.5 meters. This is at 1.5 meters. That is exactly center of BC. Okay, 60 kilonewton. Then at point D, the vertical component, it will be 200 sine 45, horizontal it is acting along the beam only. By dotted I will write here, that is 200 200 200 cos 45. Okay, now taking summation of horizontal forces sigma f of x equal to 0. So sigma f of x equal to 0, here hinged, what is the support at A in our problem? It is a hinged support, right? So 200 kilonewton inclined and inclined force is also given, right? So we will have to take here at A, RAY and RAX. Okay, if there is no inclined support, there is no inclined load given, then you can take only RA. Okay, so taking summation of horizontal forces, that is RAX is positive, then minus 200 cos 45 equal to 0. Therefore, RAX equal to 200 cos 45, how much we get? 141.42 kilonewton. So we got RAX value. Then next, sigma f of y, taking summation of vertical forces. Upward forces are positive, downwards are negative. So RAY plus RE. Then downward forces here minus 100 minus 60. Minus 100 kilonewton minus 60 minus, no need to consider the moment here. Moment we have to consider while taking moment about A or E. So minus 200 sine 45 equal to 0. So we get RAY plus RE equal to 301.42. Let us say this as equation 1. Now we have to take moment about either A or E to find out either of the reaction. Let me take moment about point A. Okay. So if I take moment about point A here, first RAX, RAY, they are not causing any moment because they are passing through point A. Even 200 cos 45 also it is passing through point A. Okay, now the moment due to 100 kilonewton, it is going to cause a clockwise moment about point A. So positive. So 100 moment means force into the perpendicular distance, right? So 100 into 3 clockwise, so positive. Then next 60 kilonewton, it is also going to cause a clockwise moment about point A. So 60 into the distance of 60 kilonewton from point A is 3 plus 1.5. So 4.5. Then next we have to add the moment. There is a 100 kilonewton meter moment. So don't multiply anything to moment. It is already a moment. It is not a force. So 100 kilonewton meter and it is a clockwise moment. So directly 100 kilonewton meter. Then plus 200 sine 45 into the distance here between C and D. The distance is 3 meters and D and D it is 3 meters. Right. So the distance of 200 sine 45 from point A is 9 meters. 3 plus 3 plus 3. So 9. Okay. Then what else we have to consider? Next is RE. RE is going to cause like this. It is going to cause about point A anti-clockwise moment. So minus RE into the distance, that is at 12 meters, equal to 0. Therefore, on simplification, we get RE equal to 161.89 kilonewton. Now, substituting in equation 1, okay, we get RAY plus 161.89 equal to 301.42. Therefore, RAY equal to how much we get? 139.52. Okay. Next, once you get RAX and RAY, one more step you have to do, that is RA equal to square root of RAX square plus RAY square. Okay. Mention answer for RA in the comment section. Okay. RAX and RAY value already we have. So tell me how much you get RA value. Okay. Next, one more problem let me solve. That is finding the distance x. They can give an unknown distance value. So next problem, there is a beam given. This is point A and this is point B. Okay. So there is first a UDL given of 10 kilonewton per meter and here there is a 30 kilonewton point load. Next there is a one more point load of 20 kilonewton and here at the overhang there is a 10 kilonewton force point load. So this is RA, this is RB The distances are UDL 2 meters, then this is 1 meter, it is 4 meters. They have asked us to find this value, that is x. How we can do it? We have to use the equations of equilibrium. First, taking summation of vertical forces, upward forces are positive, so RA plus RB. Then minus UDL will be 10 into 2, intensity into the distance over which it is spread. So 10 into 2 minus 20 minus 10. Right? So one more here 20, 10, and there is a one more point load, that is 30 kilonewton. This is equal to 0. So next what we have to do, they have given that in the question RA and RB are equal. Here they have given RA is equal to RB. They have mentioned. So RA equal to RB means this term, it will become 2 times RA. Okay. Substituting RA equal to RB. Okay. 2 times RA and it will be equal to minus 20 plus 20, 40, 50, 60, 70, 80. So 80 equal to 0. So 2RA equal to 80. It means RA equal to 40 kilonewton and RB is also equal to 40 kilonewton. RA equal to RB equal to 40 kilonewton we got. Next what we have to find is what is X value. So let us take moment about point A. If we take moment about point A, first the moment due to UDL is 10 into 2. It acts at its center. So into 1. 10 into 2 is the magnitude into 1. It is acting at center and it causes a clockwise moment. So positive. Then plus this point load 30 kilonewton. It also causes a clockwise moment about point A. So 30 into 2. Then next, this 20 kilonewton is also causing a clockwise movement and it is at a distance of 2 plus 1, 3 meters. Okay. Then this reaction at B, it is causing an anti-clockwise moment. So minus RB into, it is at a distance of 7 meters. Then this 10 kilonewton will cause a clockwise moment. So 10 into, it is at a distance of 2 plus 1, 3, 3 plus 4, 7 plus x, right? Because 4, 5, 6, 7 plus this is distance x. So 7 plus x. So we have taken moment of all the terms, right? 20 into 1 due to UDL, 30 into 2 due to point load, 20 into 3 also due to this 20 kilonewton point load, minus RB into 7. We know RB value, we'll substitute here, RB value is 40. Then unknown is X, this is equal to 0. So substitute RB equal to 40 kilonewton and simplify, we will get X value as 7 meters. Okay, they can ask a problem like this also in your exam. Then let us solve one more problem with the inclined support. They can ask a problem like this as well. Okay, so there is a hinged support and inclined load concentrated 100 kilonewton at an angle of 45 degrees and this is A, spread over distance of 1 meters. UDL intensity 50 kilonewton per meter. Here at point D there is inclined roller support. So inclined roller support is there. Now in this case, how to solve this? It is very important and they will be giving the angle. Okay. So how to find that angle and solve? Let us see. this inclined roller is there. They have given this angle, that is 1 in 2. This distance is 1 meter and this distance is 3 meters. Okay, let us say this as point B, this as point C. Okay, this is 3 meters. Okay, now this angle we want. So tan theta equal to opposite divided by to this, that is 1 by 2, right? Opposite by base. So how much you get? Theta equal to tan inverse of 1 by 2, that is angle is we get 26.56. Then let us simplify the sketch. RAY, vertical reaction at hinge support, horizontal it is RAX, right? Then let us resolve this. 100 kilonewton, vertical component will be 100 sine 45, horizontal I will represent by dotted, it will act along the beam, 100 cos 45. Okay, then the distance 1 meters. Next, this is at point B, this is point C and this is point D. Here convert this UDL into point load, that is 50 into 3. So it will become 150 kilonewton, intensity into distance. So that is 50 into 3, 150 kilonewton, right? And it is acting at its center, that is half of 3, that is 1.5, 1.5. Okay. Then this middle distance it is 1 meters. Now we have simplified the sketch. Then we have to take the reaction at point D. This is RD. Okay, and the angle we have found out, that is 26.56. In the sphere problems and all we have done that this angle which it makes, the horizontal, that normal to that plane will make the same angle with the vertical. So this RD is making an angle of 26.56 with the vertical. Okay, then once you do this much, this is very important. Okay, once we do this much, then it is very simple. That is taking sigma f of x equal to 0, applying equations of equilibrium. So Rax is positive, Rax. Then 100 cos 45 is also positive, that is 100 cos 45. Okay, then RD. Okay, we have to resolve this RD. RD will be having again two components, right? The one vertical, one horizontal. Then what will be the horizontal component? What will be vertical component? Here it will be RD cos 26.56, right? And it will be RD sine 26.56, because where there is angle, that component will be cos angle, right? So here vertical component will be RD cos 26.56, horizontal will be RD sine 26.56. So here it is acting towards negative x, so minus RD sine 26.56 equal to 0. Okay, let us say this as equation 1. Then next what we have to do is take sigma f of y equal to 0, that is vertical forces, summation of vertical forces plus Ray upwards acting positive, then plus Rd cos 26.56 upwards positive, then downwards forces are negative, that is minus 100 sine 45 minus 150 kilonewton. Okay, that is equal to 0. Then let us say this as, simplify this, that is Ray plus 0.894 cos, sorry, 0.894 times RD, okay, is equal to 220.71. Okay, let this be equation 2. Now we have to take moment and simplify the equations. Let us take moment about A. So first moment about, let us take moment of the 100 sine 45. Okay, this 100 sine 45, it is causing a clockwise moment. So 100 sine 45, it is acting at a distance of 1 meters. Okay, then next what we have to take, we have to take 150 kilonewton. It is also causing a clockwise moment. So 150 into, it is acting at a distance of 3.5 meters. 1 plus 1 plus 1.5. So 3.5 meters. Then next what we have to take is vertical, one more is RD cos 26.56. It is causing an anti-clockwise moment. So minus, it is at a distance of 1 plus 1, 2 plus 3, that is 5. So 5 RD cos 26.56, okay, is equal to 0. Now simplify this, we will get RD value as 133.2 kilonewton. Then substitute RD value in equation 2. We will get RAY value. Okay. So RAY, how much we will get? We will get as 101.63 kilonewton. Then once you get RAY value and RD value, okay, we can substitute in equation 1. So substituting RD value in equation 1. Okay. So we'll get RAX value, that is RAX is equal to, we'll get minus 7.17 kilonewton. What it means? Means we have assumed RAX like this, but negative means RAX is like this towards negative x. Only that is the meaning. You need not get afraid of it. Then find RA value, that is square root of RAX square plus RAY square. Mention in the comment section how much you get RA value. Okay. Please like, share and subscribe to my channel. In the upcoming videos, I'll upload remaining modules and many more numericals also. Okay. Thank you.